Welcome to Lesson 37, The Rational Numbers, or Rational Numbers Part 2. Now, because these come out of different books, there's one word difference, and so it seems like another lesson. But this is related to the previous lesson, so watch that video first. We're going to go a little further in this one, and you'll see the difference if you watch video 36 of numbers and operation. Here's our objective, here's our vocabulary. Here's our groups of numbers. Here's another diagram of all the number groups so far that we know about. There are more, and they will be coming. And so today we're going to identify the sets of numbers to which each number belongs. So are we talking, is it whole, is it integer? What's the smallest group it belongs to? So 7 can be a whole number, but there's a smaller group it goes back to. The smallest group it goes back to is the natural or counting numbers. It can be an integer. Well, there's no sign in front of it, so it's not an integer. But sometimes positive integers are understood if they don't have a sign in front of them. They're understood to be positive. And this is also rational. And we're going to show you how to turn a natural number into a rational number. So 7 fits into all categories. A number like -10 fits into integers, and it fits into rational numbers. And I know you're saying, Mr. Walls, I don't see a decimal point or a fraction, but I just wait. I'm going to show you. And -2/9. -2/9 is a rational number. That's the smallest group it will fit into. And that's all the groups it will fit into. So let's look at example 2. So now, let's write as a fraction A and B. Okay. So let's take -13. All numbers are understood to be divided by 1. So you can take -13 and divide it by 1, and now you have an improper fraction. Any number divided by 1 is the same number. So these two equal one another. They're equal. -13 is understood to be -13/1. So let's take this. This is -3 and 4/11. -3 and 4/11ths. Now, if you watch some of the fraction videos, you will know that the 3 multiplies. It multiplies, and then we add. And then the bottom stays the same. So we're going to have 11, a negative out front. 3 times 11 is 33, plus 4 is 37. So 3 and 4/11ths equals -37/11. And this is how you turn integers or whole numbers or natural numbers into fractions and mixed numbers into improper fractions. Okay, example 3, turn these into decimals. As you see in the last example, we've divided the top by the bottom. And so let's do it. So 5 divided by 6. So you drop the 5 down in the house. 6 doesn't go into 5 evenly. You add a decimal point. 8 times 6 is 48, and you get 2. Bring that down. 3 times 6 is 18. Subtracting, you get 2. 3 times 6 is 18. Subtracting, you get 2. You'll see this start to repeat at the 3. So -5/6 equals -0.833. Because the 6 went into the 5 0 times, so that's why that's 0. Okay, this is not 46/25. It's 4 and 6 25ths. So 25 into 6 goes 0 times. We add a decimal. You can always add a decimal at the end of a number. 25 goes into 60 twice. You get 50. Subtracting 6 minus 5 is 1. 0 minus 0 is 0. 25 doesn't go into 10. Add another 0. 25 4 times is 100. And we get a terminating decimal. So the fractional part of 6 over 25 is 0.24, 24 hundredths. But don't forget about the whole number part. So 4 and 6 over 25 equals 4.24. That is that example. And so those concludes our examples. See me at the end of the video for the recap. Okay, identify the set to which each number belongs. So, -4 and 4/5 is rational. 0 is whole. That's the smallest group it goes into is whole. Can be an integer, but that's weird. Is it rational? It could be. If you put 0 over any number, you can get a rational number out of it. So we'll just leave the smallest group for 0. And then 121 over 150. Okay, let's drop the 121 down into there. That goes in 0 times. So let's put a 0. And let's try 8. 8 times 0 is 0. 8 times 5 is 40. And 12. Carry the 4. Okay, 1200. So that gives us 10. We add a 0. 150 goes into 100 0 times. So we add another 0. And let's try 6. 6 times 0 is 0. 6 times 5 is 30. Carry the 3, 900. When we subtract, we get 100. Oh, look at that, 1,000 again. And we get 900. Subtracting, get 100. Okay, so we can see that the 6 is going to repeat. So 121 over 150 equals 0.806 repeating. Let's look at our other ones. Write in the form of A over B. So 15 and 2/3. 15 times 3 is 45 plus 2 is 47. So this equals 47 over 3. This is -1 and 1/10, which equals 1 times 10 is 10, plus 1 is 11, -11 over 10. So the rule for multiplying mixed numbers into improper fractions is multiply, add. And finally, write as a decimal, 5 over 8. Drop the 5 down in the house, goes in 0 times. We need a decimal. 6 is 48. Subtracting, you get 2. Oh, what did I do? I'm sorry. I wrote before I could think. Okay. How many times does 8 go into 20? It goes in twice. It's 16, which gives you 4. How many times does 8 go into 40? 5 times. 5 times 8 is 40. And oh, look, this decimal repeats. 5/8 equals 0.625. 1/6. Drop the 1 in. Goes in 0 times. 6 goes into 1 0 times. Add a 0. Put your decimal point up. Once is 4. 6 times 6 is 36. It's 36. We get 4, a 0. 6 times 6 is 36. We get another 4 out. So 1/6 equals 0.16 with the 6 repeating. And finally, 1/7. Drop the 1 down in there. 7 goes into 1 0 times. Put a decimal point in a 0. Put a decimal point on top of the house. 7 goes into 10 once. Subtracting, you get 3. 4 times 7 is 28. You get 2. Oh, we did this before. Bring you 0. 2 times 7 is 14. 6. Another 0. 6, 7, 49. 8 is 56. 8 times 7 is 56. We get 4. 0. 40. 5 is 35. We get 50. 7, 49. We get 1. And I think it's going to repeat. So 1, 4, 2, 8, 5, 7. All of those numbers repeat. So when you have a group of numbers repeating, you have to put your line over every number that repeats, 2, 8, 5, 7, and put your bar over that, which means that all of these numbers repeat. So we can see we started with 10 and we come back to 1. So if we bring that down, you'll do 1 times 7 is 7, you'll get 3. So you'll come back here, then 20, then 60, then 40, then 50, then 1 again. So if you keep repeating that out on a piece of paper, you'll see that those numbers repeat. And that concludes this lesson, 37, the second part of rational numbers. It had a different title in a different book, so I did not name it part 2. Thank you for watching these videos. Subscribe and hit the notification bell to see more videos.